from Toby. If you could go back and redo your robot, what would you change?
That's a great question because I am still redoing my robot. In fact, you can see it on the shelf behind me where it's currently parked. The biggest problem for me was that I couldn't pull out the electronics and show people what the insides were like. And that actually led me down the path of wanting to take all of the electronics that were on separate breakout boards with wires linking all together to try and make an all-in-one PCB, which had the kind of everything my robot needed. And that opened Pandora's box of getting me into PCB design. And I'm doing a live session on that tomorrow for people who are interested. So I won't go into all the details here, but that's the main thing I'm working on changing, is replacing the internals with custom electronics so that it's more compact and easier to maintain.
Cool. For the people who missed it, what camera did you use to do the video?
So I recorded most of the kind of talking to camera on my Lumix GH5 camera. The slow motion stuff that you saw in some of the video clips was done on a GoPro. And some of the, because I was on my own on competition day, all of the recordings of my robot on the courses was a GoPro on a tripod, which I just set up before I did the challenge and just recorded from a static camera point.
Cool.
But using the magic of video editing, I was actually able to do kind of pan and zoom around the obstacle course from that static shot because it was filmed at 4K resolution. And so you can kind of pan and zoom a HD resolution window around the frame in the editing package and actually make quite a nice dynamic shot out of the static capture of the whole course.
Great. What CAD package did you use and how did you find it?
So the CAD package I used was Solidworks. I found it extremely comprehensive, as you probably imagine, for a kind of high-end professional CAD package. I started learning it about August of before the entry application that year. So I was really on a learning curve from scratch with CAD. I'd never done any CAD before. And the initial learning curve, as I'm sure anyone who's done CAD, was quite steep. But suddenly, once you've kind of got your head around the principles of parametric modeling, which is kind of the basic way that these CAD packages work, where you start with a simple shape and you kind of extend and build on it, and learn my way around the user interface, then I was flying with that.
Well, just a question from me. If somebody wanted to get into CAD, where would you suggest they start?
If they're in Cambridge, I would suggest join Cambridge Makespace. For me, I mean, I joined Makespace shortly before that Pi Wars competition that year, and for me, the access to equipment, which is what attracts most people in the first place, actually turned out to be not the biggest benefit. It was access to the people and the experience and knowledge and sharing of ideas that came from that. And there have been a number of kind of CAD sort of classroom sessions run in Makespace, and I'm hoping to launch a SolidWorks based one as a kind of virtual session, so they'll hopefully be online. But there's a ton of really good CAD tutorials on YouTube, so the resources are out there. You just need to choose your software and put the time in to learn.
I tried it once and it was like, I've got no idea what I'm doing.
Yeah, it does feel like that at the start, but a bit of perseverance, and I found that it all kind of fell into place.
Question from Dave Booth. Did you use thread lock on any of the robots you built to stop the bolts undoing?
I didn't. I'm a big fan of nylock nuts. So they're the ones that have a little bit of nylon built into the nut, and so that grips the thread really well.
Yeah.
So it's kind of like thread lock, but it's built into the nut, and you don't have to. You can kind of remove them, put them back together again. Whereas I think thread lock, you need to reapply it if you need to take the robot apart, because it's like a sort of glue that sets.
And question from Danny Staple. Is any robot ever truly finished?
And I think you move on to another robot. But yeah, finished is I think is anyone who's built their own robots will. If you build a robot from a kit, you kind of do everything that the kit says, and you've got a robot. But once you start having that complete creative freedom to do whatever you want with your own design, then you're always learning and you're always finding new things that you want to add and enhance and extend, or you come up with another crazy robot idea and you put one aside and move on to the next one.
Or you think, oh, I'll just design my own PCB, no problem.
Yeah, you think, oh, I'll just redesign the PCB, and 18 months later, you're still working on that project.
Would you have been better off using 2 motors for the Nerf gun?
Possibly. I had the one brushless motor, and I thought, well, that's way more powerful than it needs to be. What I did do was I put a PLA roller in opposition to it, and that actually worked fine. The only problem was that the motor needed to have a grippier surface,
right?
Because the metal barrel of the motor was the friction was not enough to throw the dart out before the heat of it rubbing against the foam had melted the foam. And so the motor would just melt an arc in the side of the dart. And putting the rubber band on the motor overcame that problem and gave it the grip. But the motor span so fast that the rubber band would expand until it was no longer gripping, and then it would glide sideways, and then it would re-grip, and it would like collapse back onto the barrel, but lock the barrel against the non-rotating part of the barrel and jam the whole mechanism up. So I could maybe have glued something on. Yeah, but running it at a slightly lower speed was. If you want more power, and I don't think you need more power for this sort of application, but if you want more power, then twin motor designs are the way that a lot of the commercial units are done. I've seen the one that Brian Corteil was using in MakeSpace earlier this year, and that had kind of twin metal rotating rollers, and that would fling Nerf darts down the full length of the MakeSpace workshop at very high speed.
What question? Oh, do you have an engineering or science background that helped you with tackling Pi Wars?
So I have a science background. I'm actually chemistry trained by background, and I work in scientific software development. So my software and my science background were definitely a help. But the kind of physical engineering side was very much being learned on the fly. I should say I do have the advantage that I work for a engineering software company, Dassault Systems, whose sponsor talk is coming up a little bit later this morning. And so I share an office with the Solidworks R&D team. And so there's people who know Solidworks from the software side, but actually the place that I get my engineering knowledge is through MakeSpace members and people on Twitter. I learn almost more on Twitter from people seeing my projects. I always post my in progress kind of status of anything I'm doing. So if I've designed a new PCB idea, I'll stick it up on Twitter and get it shot down by people who know far more than I do. And it's really good way to learn, because when you make the obvious mistakes to an electronic engineer, but not at all obvious to you as someone who's learning a new skill area, they'll say kind of, have you thought about decoupling capacitors to kind of make sure that your chip doesn't stop working due to noise in your circuit? And you think, kind of noise? It's just noughts and ones. It's like pure logic. What are they talking about? And then you learn that actually everything on your PCB is a resistor and a capacitor and an inductor, because physics is there, and there's a lot of kind of design skill that they have, and that they're happy to share, and I really appreciate that input from people.
Yeah. A potentially controversial question: how much does SolidWorks cost, and is there a free version?
So there isn't a free version, but there are education licenses. We're in the process of trying to set those up for Cambridge MakeSpace members. and they do a lot of educational sales to schools. So they have kind of low cost licensing for schools, which enables people to kind of get that experience of professional CAD package. I don't have a clear idea on the pricing because I don't deal with that side of kind of the business, but my understanding is that the subscription licensing, I did a little hunting around online. Subscription licensing was kind of in the region of $1,000 a year,
Right.
for the kind of full professional package.
Okay. What was the overall cost of your robot?
That's a good question, which I can't give a clear answer to. Probably the most surprising cost was the fastenings, because it was the first robot I built that wasn't from a kit where everything's provided. I needed all the nuts and bolts. And when you go to buy nuts and bolts, you can buy kind of 5 shoulder bolts off eBay for a kind of £5 or something. But you think, well, if I buy 10, then it's £6. And if I buy 50, then it's a tenner. So I thought what I really want is a kind of fixings box, which has, I don't want to, every time I kind of need a M3 12mm long machine screw, to have to go on eBay and wait a few days for it to arrive in the post. So every time I bought a particular fixing, a particular size of screw or bolt or nut, I would generally buy 100 of them. And now I've got a big box with everything I need when I'm prototyping new robots. But the cost of buying kind of, I didn't buy 100 of the more expensive items. I'd maybe buy 25 or 50, but I bought enough that I could build probably 10 of my robots. And so that cost was a big upfront cost and came to several £100, I think. But it's kind of now engineering stock that I have, so that when I want to make something, I can just grab it off the shelf. And
cool.
The rest of the robot, I really tried hard to design it from hobby parts that were low cost, because all of the Rockaboki Mars rover designs I'd seen that people had made online were kind of running into kind of £500 to £10,000 sort of cost range. And I wanted to make something that was kind of affordable for a hobbyist. So it's got the moon buggy wheels and the micrometal gear motors. I think the motors are about £5 each, and there's 6 of them in there. And I used hobby servos; they were £5 each. So it's 4 servos and 6 motors. So that's kind of £50 of motors. The acrylic isn't particularly expensive, but the amount of acrylic that and plywood that I got through in prototyping probably meant that I used 4 times the material you see in the final robot.
Yeah.
That's kind of what, £8 a sheet. So I probably could make the robot out of 1.5 sheets. So maybe 12 quid's worth of acrylic went into it. But I probably used 4 times that much in learning.
Yeah.
And then there's some expensive components on there, like the hyperpixel display, which is absolutely gorgeous. Beautiful high resolution touchscreen. Those I think they're over £50 each, or in that ballpark.
Yeah.
So it adds up, as anyone who's built a Pi Wars robot will appreciate. There's a Pixie camera in there, and I think that was about £100.